Hello everyone, welcome to Nam's World. In today's video, we'll do some practice problems on Shift Reducing Parser. Okay, so let's see the first question. So what is the given grammar? This is a given grammar. We need to perform Shift Reduce Parsing for the input string 32423. Okay, so first you need to take the stack, input and action. In stack, always the stack starts with a dollar. Okay, and input string ends with a dollar. So first take the dollar and input string with the dollar. Okay, see, in stack do we have any element? No, right? So no elements. So shift, I'll explain about shift and reduce. Shift means if in the stack these RHS elements are present, then we perform reduce action. If in the stack this RHS, any of the RHS is not present, then we perform shifts. So here no element is there which is in the RHS. So perform shift. Since no handles in the stack, we are performing shift. How to perform this shift? First element you need to shift here. This element will be shifted here. Okay, next, do we have 3 in right side of the grammar? No, right? So again shift, since no handles in the stack, so this 2 will be shifted here. Next, do we have 3 2? No, right? We don't have 3 2 in the right side of the grammar, so shift. Next, we need to shift the 4 since no handles. Okay, next, now see, we have 4 in the stack. In the right side of the stack we have 4. This is the stack. In this stack we have the right side element, so we need to perform reduce. While performing reduce, this 4 is derived from this, right? E produces 4, so you need to write reduce E produces 4. So this element you need to pop and you need to push this element into the stack. See, I have popped the 4 and just pushed the E here. Okay, now do we have 3 2E in the stack? We don't have. Do we have only E in the stack? No. Do we have only 2? No. Do we have 3 2E? No. So we need to perform shift. Since no handles means no RHS element in the stack, we need to perform shift. Shift means input element will be shifted here. Okay, next, see, now do we have 2 in the stack? Only 2. Do we have only 2 in the stack? Do we have only E? We don't have only E. Combinations we have, but we have, see, 2E2. We do have 2E2. Here also there. E produces 2E2. So we need to reduce by this. When the RHS elements are present in the stack, we need to reduce this. This is produced by which grammar? This is produced by this first one. Okay, so we need to reduce this by this. So reduce E produces 2E2. Reduce E produces 2E2. Means in place of this, we need to pop this and we need to push this. Okay, now see, do we have 3E in the stack? 3E. 3E, not combination. Here 3 also there, but we don't have that. We have only 3. So handles not there, right, in stack. No sufficient handles. So perform shift. Shift means we need to shift this here. Okay. Now see, do we have 3 alone? Single element 3 do we have? No. Single element E. Single element E do we have? No. But we have combinedly 3E3. So we can See where it is being reduced. E produces 3E3. So we can, this can be replaced with this E. So reduce E produces 3E3. Reduce E produces 3E3. Okay. So we need to just pop this and push this here. So E and dollar, if it reaches to the start symbol, the stack reaches to the start symbol, and in input we have dollar, then this string will be accepted. So this is the process of performing shift reduce parsing. This is the first example. Let's go to the next example. So this is the next example. This is the grammar. Okay. So this is the example. Let's see it. So stack, input buffer, and action. In the stack we normally have, basically we do have dollar defaultly. You should start with the dollar only, and the input string must end with the dollar symbol. So see, we don't have any handles here. These RHS elements are not present in the stack. So shift. We'll be shifting this open parenthesis here. Okay, write the remaining input. We don't have, do we have this L only here? We don't have. So perform shift. This A will be shifted here. Okay. So we have shifted A here. Next, do we have A alone in the grammar? Yes, we have. A is produced by S. So we need to reduce S produces A. See, it is present in the, this grammar is present in the stack, right? So we are performing reduce action. Okay. So we'll be popping this and pushing this element here. Okay. Now next, do we have S in the grammar? Yes, we do have. See, L produces S, so we need to reduce L produces S. So we need to pop this and push this here. Okay. Next, do we have L alone? Single L do we have? No. This is one protection, this is one protection. We don't have. So we need to shift. We'll be shifting this here. Okay. We don't have this one in right side of the grammar. Do we have this one? Open parenthesis L comma. We don't have alone. So we need to again perform shift. This will be shifted. Next, see here also we don't have. So shift. A will be shifted here. Now we have this A in the right side of the grammar, right? So we need to reduce S produces A. We'll be popping this and pushing this S here. Do we have S in the grammar? Alone. Single element we have. Okay. So we need to reduce L produces S. Reduce L produces S. Push this, pop this S and push this L here. Okay. Next, do we have this? We don't have this. Combinedly we don't have, but alone like this we have. That will be not considered. So shift. We'll be shifting this comma here. This also will be shifted since they are not present in the RHS side of the grammar. Okay. Next, like that only we'll be shifting A here. A is present in the grammar. Since A is present in the grammar, we need to reduce S produces A. Reduce S produces A. We will be popping this and pushing this here. Okay. Next, do we have S alone? S we have. So we need to reduce L produces S. See L. See, along with S, we also have comma ls, which is also present in the right side of the grammar. So we need to reduce L produces L comma S. Okay. So pop this and push this here. Okay. Next, we don't have this in our right side of the grammar. So we need to shift. We need to perform shift. We'll be shifting this element here. Okay, input here. So we'll get like this. Do check, do we have this in our right side of the grammar? Yes, we do have. So reduce S produces brackets L. Okay, we need to pop this and push this here. So we get ls. We have ls in our grammar in the right side. So we need to reduce L produces L comma S. So in place of this, we just replace with L. Next, we don't have bracket L. Bracket L. We don't have in single list. So shift. We'll be shifting this here. We'll be shifting this here. So in the grammar we have in brackets L we have. So we can reduce S produces in brackets L. Okay. So we need to pop this and push this element here. So stack is having the start symbol. This is our start symbol. It is in the stack and input has reached to the dollar. So it is accepted.